Welcome back, everybody. Today's gonna be fun because you guys asked me for some help. You guys at the Fireball Tool Forum submitted a plan of this heat pump base, and you'd like to know how I would fixture it with the Fireball system. And that's a great question, so let me show you how I do it. And here we go, little S shape. This is in metric, and we are going to be fabricating this on a imperial table. I honestly don't really care if it's metric or imperial, everything converts over. I've modeled this in millimeters. But I'm going to show you why it doesn't matter when we put it down on the table. So we have a S shape and some angle iron brackets on here that are kind of welded on a little bit funky, but looks like it's going to be holding something on. So what I think we should start with is let's remove these angle iron brackets from this. I would like to fixture this in two separate operations. So I've modeled that right here without those on there. So the first thing I want to do is open up a table. So we're going to build this on the 10254. And then I'm going to make a assembly off of this table because we're going to be adding a whole bunch of parts to it. And in SolidWorks, it's called an assembly. So just click anywhere and it plops the table down for me. And now I want to insert my components. Looks like that. So it's actually a lot larger in CAD than what it looks like. So as you can see, I'm floating around with this heat pump stand. It's actually quite large. So now I get to pick where do I want it to live. And the first thing I'm going to do is I'm going to mate this part to the table. Put this down here like that. And now you can see I'm touching. And now I have to worry about an orientation, but we're going to worry about that in a minute. So we just need to get these two pieces running parallel, true, and to length. So I like to work off the left-hand corner and in the front, which we're going to call this 0, 0 because we're building a grid. I'm going to insert some components to get started, and I always like starting with a fence block. And all of these parts are available for download. So I'm going to plop this down on the table, and then I'm going to give it a mate and get it touching the top. And the way we do that is we just select those surfaces, hold down Shift, select this surface, and hit OK. What I like to do is position the block this way, like that, so that we're referencing the front edge. This makes the block very stable. So I'm just going to kind of line things up here where I think we're going to be, and then we're going to give us our starting point, something like this, kind of away from the edge. And like I said, any of this we can move around a little bit later. We don't like it, but we're just going to get started here. Positioning the block this way gives us 2 or 3 holes to put clamps around the perimeter, and it kind of opens up for options later. Now I'd like to have another fence block over here on the end, and the rule of thumb is we want blocks spaced as far apart as possible. And in order to get another block, I just hold Control like that, and then click and drag, and it peels me off another part. I'm going to select this surface and this surface and mate them again. Get it close like this hole and this hole. Mate, hit OK. This hole and this hole. Okay, now what we have to do is combine this block and this part together. So I'm going to select this surface and this surface of the block, and I'm going to hit mate. It's going to make that coincident with each other, and it's automatically going to straighten it up. So as you can see here, I am up against the block, but I can't move it off of it. So we need to add some more constraints. Now for this instance, let's put a block over here. This is going to give me a nice good stop. So I'm going to peel off another piece, and we're going to mate them up. Mate. Yep. Now that we know where we're at, S-curve wise, looks like if I put a block right here, it's going to give me a nice endo stop. There to there, there, and there to there. And now I'm going to bump this tube into the end of this block. So now we can see we can't slide it back and forth, up or down, in or out. That part is locked in place with this system here. So now that you have to remember, this is going to be one piece, and they kind of bent it. It looks like they wanted this to bend, but we're going to pretend that this is 3 individual pieces. So now that we're constrained, all our parts are in, nothing is going to land on the grid anymore because this is a metric part on an imperial table. So we need to have some movement. And we're going to do that with what we call a tooth block. A tooth block is kind of like a king or queen in chess. It's one of these pieces that can just almost just do everything. This block right here looks like that. And then we're going to do the same thing. And then we're endo-wise, we're going to put him right here. So I can choose this hole or this hole. It looks like I'm going to be about the same. This hole might be a little bit better. So let's just do this and this. this, and this. All right, as you can see now, this tooth block slides in this slot and it has adjustability. Now, a tooth block has these cool teeth that are normally on the bottom that lock to a washer. We don't have these in the model because it kind of bogs the machine down, but realistically what it's doing, these teeth, is that if we put a pin in this hole and this block was also up against the pin, that would be 0, which means this is as far back as the block goes. And you can see the front of this block is lined up right on the center line of the next hole over. This would be 0, correct? So what we want to know is how far forward this block is. We don't know that until we take a measurement, but I'm not really concerned about that right now. What I want to do is make the block match the material like that. So as you can see, it has shifted off the hole center to touch here. We will come back and take that measurement, how far it moved forward, and we'll note that a little bit later. But this is kind of how the tooth block works. And now what we got to do, since this piece is locked in position, we just work our way around the entire system. Now this little S-curve is a little tricky because we have to weld inside here, so we need to keep this open. We need to keep this corner open because we need a weld. So it'd be nice to maybe put something in here that's has a lot of surface area to kind of grab this. We could put a couple blocks down here too, potentially, maybe a block, and a block. But I think we can do this with a special part. So let's check this out. Insert some components here. So I'm looking for a tooth block and a fence on the end of it. And I think it's going to be this left fence, which means dog leg left. Here we go. Okay, so what we have here is a dog leg fence, which means this is the standard tooth block. As you can see, this is like the chassis of the Fireball system. It really reduces the number of parts you need, keeps the cost down, but we're able to convert it into different applications. So this fence block over here has got a 6-inch riser on it. This tooth block has what we have called a dog leg, which is a block that bolts to the front and it kicks to the left, and then you can flip it around and go to the right. What this allows us to do is just cover a lot of surface area at the same time. So as you can see, if I put this right here, it creates this long leg for me to clamp or push up against it. So what I'm going to do is I'm going to roll this block so we can mate it down to the table. Okay, I want this surface and this surface. And now let's put this right here. Yeah, I like that. So let's go this wall and this one, this wall and this one, something like this. And once again, we are sliding, and these 2 pins keep this block straight. I'm gonna make this tube with this block. Just like that. So now this block is constrained with this. So the 45s here are going to constrain this part. So there's a little bit of float here. I don't really need to constrain the edge because this part's here and this part's here. So all I need to worry about is left or right with this little piece. So I'm going to grab another tooth block. And as you can see, I just grabbed at the chassis part. And like I say, some of this you can do on the shop floor, but I just like to kind of just get an overall picture of this. That's why I like this fixturing stuff here, sitting in my nice comfy air-conditioned office, and I can get all this preliminary thinking done on my own. Okay, so I'm going to position this block probably a few inches from the edge. It's kind of my standard procedure. This block is a little tight here in the corner, so I would probably like tack it, get it all tacked, and then probably pull it out of here, but it'd probably be okay too. Let's go here, mate that tangent with this sidewall. There we go. And as you can see, we're just kind of walking all these blocks around our existing part. It's really that easy. We're converting a metric part into a imperial part. Everybody kind of makes a big deal out of it, but I don't really care. I don't need to know any math. I don't need to do any conversions. The computer's taking care of it for me. And then we're going to probably want to be over here at the end to get it down here as far as possible. The further apart our blocks are, the more accurate everything is. I could keep them spaced far apart as possible. And like I said, the rules are we want 2 pieces on every part. There we go. Now I can weld here. I can weld here. I can weld there across the top. All my welds are available, and there's nothing that can move. And from here we could clamp. Okay, so that's how I do this operation. And then once this part is done, we need to weld on those little pieces. So maybe on the other side of this table, we have op number 2, which means as the parts are coming off here, we can use this corner and make another setup. So let's bring in the other component. Insert component. This is heat pump stand with 90 metal. There we go. Yeah, so how in the heck are we gonna weld these pieces on in the right place? If we look at the part, we obviously can't weld with it sitting down here on the table because we can't get to the backside. We're gonna need to weld something like this. So we're gonna have to weld there and weld back here. So the way I kind of am looking at this is, what can we do here? We can use the side of the table. We can use the top of the table. We can bend it over the edge. So let's just play around and just play a couple of options here, because there's always more than one way to do this. Maybe we do something like this. And this is kind of what CAD allows me to do, is just brainstorm, and there's nothing permanent. So I could clamp this tube down to the table, maybe, and then give myself a couple stops here and up front. That would be pretty good. I think I'm kind of liking that. Actually, I'm thinking we could do this. Just leave that stick out in the corner of the table there. Big deal. What's that going to hurt? Okay, so let's give ourselves a couple of fence blocks, and we'll just bump this up square, and we'll make some fixturing for this. So I'm going to peel off a fence block over here. And like I said, there's more ways to skin a cat. We don't have to keep this thing this way. You guys can make your own decisions on how you'd like to do this. CAD just really gives us a cool overall view of what's going on, and we can kind of just mess around with it. So we don't want to interfere with some fixturing that I want to put back here. So I think we'll probably be okay if we put this low. So I'm going to stretch this out so we're square. Yeah, let's do this hole and this hole. There we go. And this hole and this hole. Give myself one more over here. Hang him off the table. So we do this, mate him up, and we make here and here, here and here, and now we can mate here and here. So what I would do now to kind of help keep this thing from rolling around, I would probably put one block down here too, to kind of like smash up against, so that this part, if you look at it from this angle, it might want to roll, right? Like swivel. So let's put one more block down here on the side. Then we can call it okay. So probably something like that, right? You want to go here and here. There we go. And this may not be necessary, but we'll add it there just for fun. Okay, so now we've blocked in. We could put a clamp and push against this. We could clamp down. So now this part is theoretically constrained, right? Because it can't pull back because we can clamp against the edge. It can't go left or right because of these two blocks. Now we just need to worry about these two thingy majiggies, this piece of 90 metal. So we want to keep this 90 metal from rolling, right? Because look at that, it's standing on that edge. That's kind of strange, right? So what we want to do is constrain it two ways. We want to keep it vertical, and we want to hold it right at the edge of here. So we're going to go with a tall riser because we need some elevation here. Okay, so I'm going to rotate them around like that, and we want to get as far out as possible. Further out we get, the more accurate we are. So I'm going to clamp here, I'm going to go there, I'm going to mate him up, and I'm going to mate him up to this one. Now we're slipping and sliding. Now I'm going to grab this to this, and I'm going to mate the surface up to the surface. There it goes. It just popped his way in there. Look at that. I like it. So now you can kind of see what I'm doing here. I'm going to explain why I did this here in a second. Never make the assumption that your parts are cut correctly. I've made that too many times in my career. Things just happen. And so now I mate this piece and this piece, just like that. Why did I do this? Well, for one, I'm square with everything because I'm using the grid. Now, if this piece right here was cut a little short for some reason or didn't match up to our jig down here or whatever weirdness, I'm going to see it. Like this piece changed from this dimension over to here. I don't know, maybe somebody cut it short and I had to fudge it because this was a folded section. This part theoretically could still be in the correct place. It might overhang a little bit, might have a little offset there or something because this is in the correct spot. I could make that call on the shop floor, but this is going to ensure that this is square and perfect. And then from here, what I can do is I could clamp it back, put a clamp in here and hold it back to the part. I don't think I would need to worry about teeter-tottering it too much. I could always just grab another section of this box tube that I already have cut and put it under here as an extra shim, per se. This is a 400 millimeter, if I remember right, tubing. So you could use some shims to keep this elevated if you needed to. All right, and now I'm just gonna do the same. Can I do the same for this other side? I think possibly. So if you look at the blocks, the Fireball block doesn't have like a brace on the back of it. So I'm gonna use this back of this block to do the same thing over here on this other side. You kind of see how I'm hanging off the table, or if I were to position it like this and mirror it over, the L would be off the table. So what I want to do is do it just the same way, but I'm going to use the back side of the block. So I'm going to mate him up with the table, all right, and I'm going to get him right here in the same hole. Yep, slipping and sliding. Okay, and what I'm going to do is use the back. I'm going to use this side of this block with this side of this. And you start to see how flexible this system is. And there you go. And then I will do the same thing over here. Neat. Yep. And then this is a pretty fun one. I know it looks really simple and you're like, what the heck, Jason? Why would you do all this? This is so silly. But in all reality, even the simplest parts I've seen get screwed up. Okay, there we go. That's how I would do that. This is setting elevation. If we wanted to set another shim underneath here to help with keeping it teeter-tottered, we could do that too, but this is just 400 millimeters, so we could add 2 blocks. We sell 1, 2, 3 blocks that could go underneath here, but it may not be that critical either. Oh, endo-wise, let's talk about that. What are we at set for endo? We're a little bit off. I'm looking for something to set endo here. So maybe what I'll do, because right, this part can shift left or right. How do we find center without even measuring? That's important. I think what I want to do is move this over 1 hole to the left. This one to this one. Here we go. This one to this one. So now you can see I gave myself a little wiggle room here. So what I want to do is I want to grab this block. Again, we're going to give ourselves an endo stop, right? That way we don't have to do no measuring. We can just plop our part in and go to town. Now, one thing you guys are going to notice about the Fireball system is that our blocks are 2 inches wide and our grid is 2 inches wide. So theoretically, we have full coverage across this entire part. So if these were to sit shoulder to shoulder, there would be no gaps in between our fixtures if we plopped them all next to each other. So I have quite a bit of coverage which side I want to pick. And I think I would probably go somewhere like this. Click here, mate, yep. And then click here, mate, yep. And then we would do here and the end of this guy. Mate. Okay, so now I have an endo stop. So I could plop my part in here, set them on top of this guy, run it up against these 2 stops, and bump it endo into here. And that would save me from 0 measuring whatsoever. So let's just recreate what I did over here on this one real quickly. Let's best it back up. And we just slide them over. This is looking excellent. There we go. Well, let's grab this guy. There we go. We want this one. I'm gonna make the assumption that there's 40 of these things to make. So the 15 minutes that we spend here in CAD is going to be well worth it, especially since we probably know this is going to be a reoccurring project and the customer is going to want us to remake these all the time. So having a fixture map ready to go. Okay, so this one, I have a little bit far left. This hole probably would have been acceptable, but when I get down there to the shop floor, I can make that decision and just move it over a whole set. It's not a big deal. Okay, so that's kind of how I would fixture this. So now how do we get all our measurements? We've got 2 ops, first op, second op. So if you had some sort of divider here across the table, you probably could have 2 people working on the table here and here. Okay, so what we want to also add in is a scale. We don't know what hole is what hole. Now what we have is this cool little scale here. Let me show you how that works. Now putting scale on a table is kind of tricky because we're on different sides of the table. So we've kind of come up with this solution where this is just a part. We'll zoom in on this and we're going to line them up pretty close like that. If you look at it, it's just an extruded text that's floating in air. Okay, so we got our scale in and now we're going to make a drawing from our part. A drawing from assembly. I already have a template here. Now what I want is just the top. There we go. Now I know as you can see this is too small. So we're going to scale it up. And I think we're going to use a custom scale and I'm going to start with something about 8. Kind of where I always end up, 7, 8, 9, 10, something like that. Now from here, what you're going to notice is the fence blocks, those already have their hole ID. What we need to hole ID is the tooth blocks. So we need to know the center of this hole to the center of this slot. basically. If this were to pull back and these were get slotted out together, how much further forward has this moved to touch this surface? So what we can do is we go in here and we add this. This gives us the center line of every circle. Now SolidWorks is a little funky. It kind of wants me to put a point here. Also, the measuring device doesn't really want to grab it very well. So I like to add this little center on all of these. It just makes SolidWorks that much better. I can see underneath here that I have an indicator. Just click on that. Even though it's hidden, it is still there. And we just go around the whole project. Our tooth block is really popular, so we're gonna have to do this to all of them. You can see this one's barely shifted forward. That's good. And when we get down on the shop floor, I'll show you all this. Okay, hit exit, and I'm gonna hide that center line because it gets confusing. I think I got it all. So now we just take our smart dimension tool and we just go around and click here and here. So 11/16 is what this is extended. So I know I'm in 16ths measurement in the model, and you can check that by going down here to edit unit documents, and I'm in 16th of an inch fraction, and I know it's going to round to the nearest fraction. So worst case scenario, we're going to be approximately off 30 thousandths is the maximum we're going to be off. Now see how these are in the same line? This is all in J. Technically, I don't really need to dimension this one because I know this is straight and parallel, so it's kind of redundant, but I'll just do it anyway. You can see how it just kind of crowds the map a little bit. But so generally, if this was for me, I wouldn't do this. I'd just automatically know that that's the same. This is 1/16. And one more over here. This is the extension, how far off it is. And this number is going to correlate with the scale on the side of the tooth block. And I'll show you that downstairs. This is the magic number. This is the one we want. This is what we've been trying to get to. So we've just taken a metric part and we've now converted it into imperial. And here we go again. Remember, these are the same. So they're just redundant, over defining these parts because obviously they're exactly the same. We just put them in a spot that's clear. There we go. Now we can go down and set this all up. We got 2 ops. This is the easy one. This is the second op, and we're good to go. You don't need to think of this trying to fixture it all in one thing because it's just too tricky and it's just kind of unnecessary. Just think of this in 2 operations and you'll be good to go. So let's go see how this looks on the shop floor. Now that we're done with CAD, I've printed myself off a fixture map. Now this is the time where I'm going to take account of all my parts and get them all laid out on the table. We have our tacking bolts, our fence blocks, our tooth blocks and washers, and our risers, and our alignment pins. I'm going to show you how to use each and every one of these components. So the first thing we're going to do is use our fence blocks. These are the most simplest components in the Fireball system. It's a 1x4 bar with holes drilled in the top and removable pins on the bottom. These are threaded in and it looks just like a Lego. Okay, what we can do here is we can bolt this block into place by replacing this with a bolt, or just use it like a regular pin and it drops in the hole, just like we did in CAD. And all I'm gonna do with these is follow the fixture map that we've already designed. So a good example, we're gonna look at this block and it's in row H. Just look at the map, and that's exactly what we have here. Identical, and I'm gonna use the same process all the way around the table. 20 and then 37. Okay, that was done. That's easy. So now we're gonna work our way around with the tooth blocks. This is a tooth block. It consists of 2 parts. One is a base washer with teeth in it that corresponds with teeth on the bottom of the slide. What happens here is the washer goes down into the location that we've set up by the map. The top goes over the top and indicates it. If you take a look right here, the holes that we talked about in CAD are concentric with each other. They're nice and neat. The slot and this hole are lined up. This is indicated right here by this little indicator as being 0. So what we do is we find out where this hole goes with our map. So we're in hole 39-4. I'm gonna put the washer down first. Then I'm gonna put the block on. It doesn't need to be in any particular order, followed up by the bolt. And this is the tail dragger. This keeps the alignment from this thing from pivoting. This is just a slip bolt, okay? And before I tighten this, you see how this slides and the bolt stays still? That is 0, all the way back. Remember in CAD we talked about how far forward the block needs to slide? Well, that was what our measurement was before, and this one, in this instance, is 5/8 of an inch. okay? And I'm there indicated on the side. And once I'm locked in place, I'm good to go. This is locked in and it cannot move. And we're gonna follow this exact procedure all the way around the table, and that's how that system works. So the next block is a little different. This is our same tooth block, but we've required a dog leg. So this block has a little cutout in it with a corresponding pin, and it drops in to the end of that block just like that. And because we have two machined surfaces right here, it locks this at a 90-degree corner. So to permanently lock this in place, this dog leg has these little tapped holes in it that correspond with those holes. So I put these together, flip it over, and I use these socket-headed cap screws with a screwdriver, and in just a few seconds, these two parts will be one, and we can confirm that it's 90. There you go. Now we follow the same map that we did in CAD, and we put it right where it belongs. The position of this tooth block requires a 1/16 of an inch washer. So if you look here, we have two washers. One's at a 1/16 of an inch offset, one's at an 1/8, which basically means that these teeth are moved back 1/16 of an inch. Okay, and we do this to avoid confusion so that you know you have the right dimension because you have the right washer underneath of it. I want to just be able to look at this tooth block and go, yes, that has a 1/16 of an inch washer underneath it, it's right. That's why we have two different washers, so that there are no mistakes. H21. And this block calls out for it to be a 1/16 of an inch out. And there we go. We have a nice grid line there, and we can eyeball it up against the grid. And if we want to, because there might be a little side pressure on here, we can use a wrench on a screwdriver. You can put it in the bolt and just give it a little crank. And then no matter what we do here, this block can't move. Got a nice 90-degree corner. 17J, 11/16, 8, 9, 10, 11. And I just hand tighten them. If you want to come back with a screwdriver, you can do that. And the cool thing about this system is that I already know where this block is. I already know what this row is. I just line it up. I know I'm in 1, 2, 3, 4. So there's no guessing, there's no measuring. Haven't pulled out a tape measure, not once. 8, 9, 10, 11. Okay, now that we're done with operation number 1, let's work on operation number 2. Now I've moved the camera around and we're at the other end of the table on the opposite corner. Now this operation requires us to continue to use the tooth block, but we need a riser on it because we've gained elevation. Now I'm going to be using a 6-inch riser that has a pin on the bottom. And once again, we can configure this tooth block any way we want. It gets inserted into the front of the tooth block. There's no orientation left or right, but at the bottom, we have these tapped holes that correspond with these holes on the bottom of the tooth block. Just insert it like that, and they just get hand tightened. And just like that, we've converted this tooth block into a 6-inch riser. So normally a table company would make you buy this whole piece, and this would be all welded together and you couldn't exchange this out. I don't like that idea. For every application, it's good in some, but I like being able to convert and utilize these bases as much as possible. I think it reduces the tooling cost and it gives you a lot of flexibility because this whole system is modular, right? But I've converted the tooth blocks into the risers. Now we can continue along the process of setting them all up. So we're still continuing to work off the same grid. Just because I'm upside down and on the other side of the table doesn't mean these whole numbers change at all. Okay, so I'm in hole 32, extended 9/16. Look at that, we're doing good. Now a couple fence blocks and we're done. So this part hangs over the edge and drips down. So we gotta stop here, gotta stop here, and we gotta stop there. That's it. Now it's ready for all my parts to be cut and I get to lay it all in there and go to town welding. Well, we got fixture 1 and fixture 2 map all done. This turned out so good. This was so fast and easy. The Fireball system makes this just a breeze. Mwah, it's the chef's kiss. I didn't even have to pull out a tape measure. What I love about this system is I can file this fixture map away for a later date if this job comes around again. Or give this map to somebody who may not be quite as well trained in fabrication. They can have a lot of success with this system. I can double check myself and make sure that I'm not messing up. But overall, this is so simple. This is why I love the Fireball system. And I know you guys will too. If you guys would like more help with your fixture maps, leave those at the Fireball Tool Forum. I'd love to help you guys there. But I hope you guys enjoyed this process and I'll see you guys on the next one.